Welcome everybody to the Daily Space Weather. Congratulations on realizing our channel exists. Yesterday we saw a massive X-class solar flare, an associated proton event. There's a coronal mass ejection headed our way, which should lead to a Halloween geomagnetic storm. Here's a couple M-class flares and the X-class flares and 131 angstroms that led to this situation. We're going to mainly be looking at full disk views of the sun today because there's so much activity going on. Here's a close-up of that active region. Sunspot 2887 is where that solar flare and coronal mass ejection emanated from. Let's take a look at stereo A and Velasco C3. So from this perspective over here on your left, that's stereo A located out here at Lagrange point 5, which puts the Earth off to your right. The blue imagery here on the right is at Lagrange point 1, which puts the Earth behind the instrument. In other words, it's directly between the Earth and the Sun, about 1 million miles toward the Sun. So there's your two views from Lagrange point 5. You can see stereo A getting peppered with some relativistic particles as well. We'll get to it in a moment. This sort of stuff can prove fatal to people on spacecraft. They need to get into radiation-shielded rooms when stuff like this happens, folks. It's pretty serious. And we'll also see ongoing high-frequency radio disruptions around the poles as there are a bunch of protons up there creating absorption in the D layer of the ionosphere. So anyway, there are your coronagraphs. If you want to see more stunning imagery close-up of the sun about this thing from yesterday, go look at our Daily Space Weather supplemental video. This is another 24-hour SDO animation. That's ionized helium, 304 angstroms, one of my favorite wavelengths. Here's ionized iron, 171 angstroms. Probably my favorite overall wavelength. Additional flaring happening here from sunspot 2891 as well. We'll be keeping an eye on the whole thing, and when I say ion, pardon the pun. The radio flux is up to, I think it's up to 114 now. There's the one-year chart to put it in context. It's the most proportional data set we have to sunspot number. So the black line is the radio flux, red line is the sunspot number. And here is the Noaa Forecast. You can see late in the day tomorrow, expecting a big increase in plasma density and the velocity, the onset of that coronal mass ejection strike. It's expected to last for about 24 hours there, well into the day on Halloween. So another Halloween geomagnetic storm here forecasted. The radio flux now 112. That's the current state of the radio flux. 112 solar flux units. So yeah, starting midday tomorrow, we're expecting some geomagnetic unrest and then a significant storm. Noaa forecasting a KP7 event, which could indeed cause things like power outages. Most modern nations have circuitry on their transformers to prevent this sort of thing, to shut down their systems when they're getting too much induced power. And let's talk briefly about that. If you scroll down to the bottom of any of these Space Weather Prediction Center pages, as so, you can actually monitor Earth's geomagnetic field right here. There you go. There's the empirical 3D model. You just press play. It'll show you a nice animation there showing you estimates of induced power in the grids. So that'll give you some assistance if you're trying to figure out what parts of the grids are going to go down and so on. We'll be covering that in the coming day or two. We'll take a brief look at seismicity, earthquakes. As they've been pretty low, we're seeing a bit of a 7 magnitude earthquake drought again, as you can see here in the 90-day bar graph. No major quakes. There was a 5 near the Aleutian Islands. We're just going to scroll up the list briefly here. Micronesia also saw a 5.0 magnitude earthquake. Philippines saw a 5.2. I think that might have been the largest of the past 24. That was at depth. Over 175 kilometers, estimated depth on that. South Sandwich Islands still rocking there with a 4.9 and a 4.6 to close out the list. And here's a La Palma volcano. Looks like things have calmed down a bit there. It doesn't appear to be currently erupting. That's a live webcam from Chimedia.es/es/play. Chimedia.es/es/play if you want to watch it yourself. So volcanodiscovery.com listing it as a 10,000-foot ash plume. It looks like a 0-foot ash plume at the moment. Explosive activity continues at Subanose-jima, though, 9,000-foot ash plume there. Samisa-Pochnoi in the Aleutian Islands, producing a 7,000-foot plume of volcanic ash as it explodes. Sangay exploding, 19,000-foot ash plume from Sangay. Revenador, also in that same country, 16,000-foot ash plume as it explodes. Sabancaya, sporadic emissions of puff. Sporadic puff pass emissions of volcanic ash are sufficient to remind us not to pole vault the caldera. Do enter the neo-renaissance. Congratulations on realizing our channel exists once again, folks. Visit our own homepage. Click on smAsho merch if you'd like to pick up merch. Click on Smash Team if you'd like all kinds of additional information nobody else gets. There are 2 paid levels, a yearly paid-up annual subscription level, as well as a free level for bronze. I would remind everybody to please forgive, remember, and hold accountable. Holding a grudge is like ingesting poison and expecting the other person to die. Universum liberate. Even if you must be liberated from your own nonsense, please do. We prefer for you not to be ossified in your beliefs. We want you to Mansa make America not suck again. Indeed, make Earth not suck again. We want you to join the Smash Team. I don't care if you're vaccinated. And please do not pole vault the caldera. It could be unhealthful. So here's the GOES magnetometers over the past 3 days. We're seeing some little higher readings here in the GOES magnetometer data. That's 3 days of information from the GOES 16 and 17. Let's take a look at the ecliptic plane field plot view here. It's the heliospheric current sheet. And Earth has now snapped across into a North Pole current sheet. An indication perhaps that sunspot 2891 will degrade. That's this sunspot up here. Although we have seen some flaring out of it, I think the umbrae are too close together for that to be able to sustain itself. I think they'll cancel each other out in the coming day or two. Anyway, that's the line of sight ecliptic plane field plot. Here's the coronal hole line of sight plot. And you can see progression of cycle 25 happening here. North Pole oriented coronal holes here around sunspot 2891 as well. You can see them in green. And here's a visualization of that from the SDO. You'll also see radial waves here spreading across the sun from the site of that solar flare and coronal mass ejection. Radial waves, folks. Radial waves, by the way, can't happen in a gas. That's not the way the physics works. Let's continue on. Here's some more imagery. Solar flare warning remains in effect. Coronal mass ejection warning remains in effect. Yeah, that's right, for additional ones. Sunspot 2887 is certainly still capable of producing major flares. Sunspot 2891, not doing a bad job either. It's also beta gamma class. So coronal mass ejection warning and solar flare warning continue. Here's the closest star in 1700 angstroms. This is just extreme ultraviolet light. It's good at showing those dark umbrae. And you can see 3 large ones there that are approximately the size of the Earth or maybe even a little bit bigger. So it looks like 2891's got its umbrae spreading apart here, and that is a feature we often see before additional major flares, as plasma can't be suspended at that great of a distance. Anyway, here's the GOES X-ray flux over the past 3 days. You can see that X-class flare. The peak flux on that was at about 1530 universal time yesterday. And here's your proton event. And we'll show you the polar regions and the blackouts and so on here in a minute. So yeah, significant proton event here, not ultra high density. And the majority of the coronal mass ejection will miss Earth. So here's your deabsorption regions predictions. And you can see, as we forecasted yesterday, there's an ongoing radio blackouts scenario, especially for the southern hemisphere, because it's spring down there. It's fall up here, which is actually a good thing because there's a lot more people associated with the North Pole than the South. You can see those additional flares coming in here in the past 24 hours. That X-class flare produced a massive radio blackout over the entire continent of South America, parts of the southern Atlantic Ocean, a large portion of the Atlantic Ocean, and an even portion of the Pacific Ocean. So again, that radio blackout you see there, that's absorption in the D layer, where your photons, instead of getting refracted back to ground level, go off into space or get too interfered with to be coherent. deabsorption regions. It's the ionosphere layer. Next, the real-time solar wind, very slow solar wind speed. So we're expecting a huge uptick in the solar wind speed and density when that coronal mass ejection strikes about midday, a little before midday. Tomorrow we're expecting geomagnetic unrest to set in. Current conditions less than 300 kilometers, only 286 kilometers per second for the solar wind speed. Solar wind density just under 7 protons per cubic centimeter. And the fact that the BT-BZ has gone into positive territory here, see that red line there? That's the BZ. And that's associated with the North Pole. So that's actually a good thing. That will reduce the amount of geomagnetic storm power. Continuing on, the KP index is at 0. No surprise there with such a slow solar wind speed. Here's the geospace over the past 4 hours. Expecting it to look pretty homogeneous here. This is the space weather modeling framework model, by the way. And the scale here is nanopascals, magnetohydrodynamic pressure. Nothing to write home there over the past 4 hours. No postcards about that. Next, ground magnetic perturbations. We show it daily since there's a polar excursion going on. We want to show our viewers on a daily basis where the changes are happening in Earth's B field. Geospace delta B would be changes to Earth's B field, the field that goes through a magnet. Not a lot of perturbations there, not a lot of induced magnetism from incoming solar protons. Continuing on, here's a chart of the solar system. And in 1 week we'll be at a new moon. Let's advance the chart for a forecast for the solar system. And there's where things will be in a 1 week. Reverse werewolves will be at the peak of their powers on the 11th of November. Only 3 days after All Souls Day, yeah. You know about All Souls Day and All Saints Day? Yeah, Halloween. It's a pagan holiday. The Catholic Church decided to answer to Halloween by creating All Saints Day on November 1st. The Protestant Church decided to answer the Catholic answer with All Souls Day on November 2nd. There's a little history for you about Halloween and the following holidays. Here's a star chart, and you can see the ecliptic and the galactic plane are crossing right above my head at the moment. The moon is approaching the apex of its flight across the ecliptic, this yellow line, the path the sun will take across the sky. Continuing on, today's cosmology segment will be very brief. There's too many things to cover. And we've got an apod.nasa.gov astronomy picture of the day. So this is the Cepheus flare region. You can also see NGC 7023, the Iris Nebula right there, featuring a bunch of emission and absorption features. If you want to go look at it yourself, or perhaps make this your computer desktop, it's at apod.nasa.gov. There's nothing random about that or our cosmology segments. Check out the playlist, youtube.com/smashamash/playlists. Over 200 videos on our cosmology segments. Next, charging hazards. We've got some estimated charging hazard quotients here, but no immediate spacecraft charging hazards shown on this. Continuing on, here's the 1-year chart of the relativistic electrons, because that's the next realm that we're going into, the electron flux. It gives us insight into Earth's magnetic fields. Here's the 3-day chart of it. We did see a spike come in. Those probably are solar electrons there, I would have to say. They showed up around the same time as the Proton event, which, by the way, only took about 1 hour. Those protons were traveling at about 23,000 miles per second. 23,000 miles per second, about 1/4 the speed of light. Here's the forecast model for relativistic electrons. And we can indeed expect to see lower levels here when the geomagnetic storm, when the CME strike happens. Expect to see cratered, very low levels of electron flux throughout that. Here's a diagram of the Earth's Van Allen belts. It'll show you distances in miles. Here's the total electron content forecast, and we're seeing continued chaos here. High levels of electron flux over the North Atlantic, North American continent, and just in general. So while the total levels of electron flux didn't really reach warning levels, we're seeing some jumbled up electrons here in some highly concentrated portions. Those will cause massive GPS errors in those areas. The areas that are showing up reddest, they usually occur around the equator at noon. Now we're seeing some chaos. Next, we're going to show you the ionosphere, and we're expecting some anomalies there. The F ionosphere is located at about 300 kilometers of altitude. Here's that slice of the complex vibrational nature of what's going on above your head. If you're scared of CERN, you should probably understand this, as CERN isn't scary, and really this isn't scary either. Yeah, the sun's not going to kill you, and neither is the core of the galaxy. If you're scared of that, take a real astronomy class. Get out of third grade astronomy thinking. Anyway, that's your ionogram. Let's pull up the anomalygram. And you're seeing some massive low-frequency anomalies here in the Central Pacific. Also the Middle East. You can see those dark red areas there. Those are 3 megahertz below normal. Also West Africa, the North Atlantic. And wild swings in the frequency around the South Atlantic anomaly, which is now on the South American continent, by the way. Maybe we ought to change the name to the South American anomaly instead of the South Atlantic one. Anyway, there's the 845 view. There's the ionogram. There is the anomaly map. That's that's the anomaly in megahertz from the 30-day median. Meteorology segment complete. They premiere before the daily space weather videos. Here comes bonus features, starting with the Lermonth ground-based solar observatory, located in Lermonth, Australia. So there's the latest hydrogen alpha imagery from that. You can see some brightening here of sunspot 2891 as it starts to produce some flares. Solar flare warning and coronal mass ejection warning continue. Let's refresh the latest intensity gram. And so these sunspots are still beta gamma class sunspots, folks. They are still certainly capable of producing major flares, especially these two. Much less so on this setting one over here. That's only an alpha class sunspot. So there's the latest magnetogram. Very high resolution for you there. That's 2887. And then we'll go up and take a look at 2891. There it is. And we'll close that with 131 and 94 angstroms. This is 131 from the SDO. Depicting that X-class flare and some M-class flares as well. Yowzers. And here's 94 angstroms. Just spectacular imagery from the SDO here. Once again from Smash staff and I, thanks for tuning in, folks, and may that solar wind be at your back.